welcome to this new video. So in this video we are going to combine or extend our previous video where we covered a table question and answering model. So in that video I would have explained what the limitations of the model, that it had only a limited context window and because of which only a set number of rows could be given as input and it can only answer based on that. Now let us say if I have a dataset that has say 10,000 rows or 1 million rows, then how can I use such models, or what are the other solutions possible? So here what we do is that we go with the generative AI models, particularly the text generation or the instruction tuned model that can write codes. So for this particular use case we are going to go with the Meta Llama 3 8 billion model. So this is a recent model that has been released by Meta. And this has proven to be very good open source model that has the ability to follow a write instruction as well as write codes and as well. So what we are going to do in this particular case is that, similar to the previous case, we are hosted this particular Llama model in the LM Studio, and then we are going to use Autogen to run this model. Now one of the benefits of using Autogen is that similar to the previous RAG approach, Autogen agent can be configured to execute certain codes that are written in Python. So what we are going to do in this entire step is that we are going to make the Llama 3 model generate code so that it can go through this particular sales data and then give us the answer, as well as generate plots for those particular sales data. So what we are going to do, we are going to import the model. So this is the model which we are going to import. Now once we import this particular sales report, what we can type any query we want, and this is the sample 5 rows which we get, just to have a look at what are all column headers etc. are there. Now let us say I want to calculate the average sales in February. So we get the result. So it has you can see that after running the code, it summarizes the answer for us. So it just indicates that the code has been successfully executed, and the output we get the average sales. By running the code, we get the average sales in February to be $1,253. Now after that, it generates a plot to see the distribution of sales in the month of February. So as you can see that we can get the plot, and we can also download the plot so that we can save it later, and this is really helpful in this particular use case which I have demonstrated in sales data. So usually the people will have to go to Excel, write certain formulas, then generate chart and modify those things, but with the help of generative AI we can really generate such plots and customize those plots according to our needs just by giving that information through the prompt. So this really speeds up the process of say if a person wants to generate a PPT to showcase various findings from the sales data, so they can use such applications that are built in that analyzes the data and provides them with charts. They can directly just copy paste and provide use those in their presentations. Now one thing to note here is that since I am running the model locally and since the model does not fit entirely onto my GPU because I have a limited GPU RAM of only 4 GB, you can see that the time taken to process becomes 65.75 seconds. So this is not ideal in this particular case. Now we can do a comparison of by hosting this model in a cloud instance, as well as by using the GPT 3 or 4 model to see the comparison. Now in order to host the models or use cloud-based open source model, the one solution I would recommend, especially when during the prototyping, is a service called, or a company called as Deep Infra. So they provide a various list of models that we can directly use, and they run entirely on their end, and they just provide a API key similar to how we have with respect to OpenAI. And we again, the pricing mechanism is very similar to that of the OpenAI, where we have to pay for the input and output tokens. Now, by using this service, we can generate. So I have already hosted this model onto my account. So to host that, we can just go to this particular thing, and you can configure the settings and then host it onto your account. So once you log in and host it on your site, we get to see, if you go to the deployment option, we get to see what is the model that is being hosted over here, and we can go and see the list of models we have hosted. And for hosting, we don't have to. Yeah, so once we host, log into our account and host it, you can see the deployment over here, and we are going to use that model into our app. Now let us try running the same query and see how fast we can get the answer. So now we get the answer. So we get the answer to be the code has been executed, and we get the same average value, and this time it has plotted a new plot, whereby it has plotted a line plot of the sales amount in February in year 22 and 23. So since we did not specify any kind of plot details regarding the plot, this time it has plotted a line plot. So again, with respect to the query or the prompt which we give as input, we should be as specific as possible to get the more consistent output. And this time, as you can see, the time taken is much less at 36 seconds. So when we are actually going for a cloud hosted solution, we get much faster times for getting such outputs. So it really helps in improving generating plots and finding quick answers from any particular data set. And in this particular case, we are using a sales report. So hope you have learned a lot from this video, and if you want similar implementation or proof of concept development, feel free to contact us, and also don't forget to like, share and subscribe the video.